So no, we can't do that. But there is another approach, and it's called doing a controlled experiment. So let's talk about what we mean by a controlled experiment. So controlled experiment involves creating two groups and then actively assigning people to one group or the other group randomly. Now, this is not really possible for this particular example of smoking. You'll see why in a minute. So we're going to have one group called the control group, and another group is going to be called the treatment group. And the idea is that we're going to call smoking the treatment. Now, usually this is not, we're not, the example is not smoking. It usually has more to do with, suppose we develop a new medicine and we want to test whether it's effective. Here we're saying that we're developing a new cancer creation behavior, which is smoking. Anyway, but so we're going to call smoking the treatment, and we're going to call people who are not smoking in the control group. So the people who are smoking are in the treatment group, and the people who are not smoking are in the control group. Now, the idea in general, it doesn't work in this case, is to randomly put people in here and here. The reason I say it doesn't work is you can't randomly assign people to this group and say, okay, now you smoke for the next 20 years and put people in here, and you say you can't smoke. We can't do that. We're prohibited from doing that for other reasons. So we can't do this kind of experiment for smoking. But anyway, this is the idea of a controlled experiment. So the important point, though, is to randomly assign people to this group and to this group. So what's the benefit of doing this? What does the random assignment do? Well, if I randomly assign people to here and here, then there's no reason to believe that people in here are going to drink more coffee than people in here. There's no reason to believe that people are going to drink more alcohol in this group than in this group. There's no reason to believe that they're going to do less exercise in here. And not only that, those are just the three confounding variables that we thought of, but for every other possible confounding variable, we should have approximately the same percentage in here as in here because we did this random assignment. So that's the advantage of doing this random assignment. We basically eliminate all the confounding variables. Then, if we find a difference between here and here, we can say that it's not because of any of the confounding variables, because they're evenly distributed here and here. It must be due to the only difference between these two groups is that this group is getting the smoking and this group isn't.